Introduction. Good morning, class. Today's lecture is about building information modeling, commonly known as BIM. Building information modeling is one of the most important developments in the modern construction industry. It has completely changed the way buildings and infrastructure are designed, constructed, and managed. What is building information modeling, BIM? Building information modeling, BIM, is a digital process that involves creating and managing a 3D intelligent model of a building or infrastructure project. This model does not only show the shape or geometry of a building. It also contains detailed information, such as dimensions, materials, quantities, structural details, mechanical, electrical, and plumbing, MEP, data, time, schedules, cost information in simple words. Backhand index pointing right. BIM is a digital representation of a building with complete information throughout its life cycle. Why BIM is needed in construction? Traditionally, construction relied on 2D drawings such as plans, sections, and elevations. These drawings often caused design clashes, errors on site rework, and delays, cost overruns. BIM solves these problems by allowing all stakeholders to work on a single digital model, reducing mistakes and improving coordination. Key components of BIM is based on several important dimensions. 1. 3D BIM. Geometry shows the actual 3D model of the building, helps visualize the project before construction, makes drawings easier to understand too. 4D BIM. Time, scheduling. Links the model with construction schedules, helps plan construction sequence, improves project planning and progress tracking. 3. 5D BIM. Cost connects quantities with cost data, helps an accurate cost estimation, reduces budget overruns. 4. 6D BIM. Sustainability used for energy analysis, helps design energy-efficient buildings, reduces environmental impact. 5. 7D BIM. Facility management used after construction, helps in maintenance and operation of buildings, provides long-term asset management data. How BIM works in construction projects. The BIM process starts from the conceptual design stage and continues till operation and maintenance. Architects create the architectural model. Structural engineers add structural elements. MEP engineers integrate services. Civil engineers coordinate site works. Contractors use BIM for planning and execution. Owners use BIM for facility management. All professionals work together on a shared model, improving coordination and efficiency. Benefits of BIM. BIM offers many advantages in construction projects. Better visualization. Clash detection before construction. Reduced errors and rework. Accurate quantity takeoffs. Better time and cost control. Improved collaboration. Higher construction quality. Reduced project risks. BIM for civil engineers. For civil engineers, BIM is extremely important in structural modeling, quantity takeoffs, construction planning, site coordination, project management, infrastructure projects like roads, bridges, and dams. Civil engineers use BIM tools to ensure safety, accuracy, and efficiency. Common BIM software. Some widely used BIM software includes Autodesk Revit, Navisworks, Civil 3D, Tekla Structures, Bentley Open Buildings, ArchiCAD. Each software serves a specific purpose in the BIM workflow. Challenges in BIM implementation. Despite its advantages, BIM also has challenges. High initial cost of software. Need for skilled professionals. Resistance to change. Training requirements. Data management issues. However, with proper training and planning, these challenges can be overcome. Future of BIM. The future of BIM is very strong. BIM is being integrated with artificial intelligence, AI, virtual reality, VR, augmented reality, AR, smart cities, video Bonake YouTube pa upload, Kernahai ESK according MJY, cinemated visual